So my name is Alex. I've been working with MySQL for probably too long, since 2006 when I joined MySQL AB. And then I worked for Sun Microsystems Oracle as a part of acquisition of MySQL. Worked for Percona for about 5 or 6 years, and recently I joined VirtualHealth, which is a medical startup in the United States. And we're basically doing a software as a service for medical insurance companies. So today I wanted to talk about how to protect personal data in MySQL that applies to medical data, to what we called PHI, personal health information, but also applied to any other information that needs to be protected. So what do we have? What kind of requirements do we have? So first of all, we need to ensure that data is encrypted. And with encryption, we basically distinguish between data in flight, basically a network part of this data, and what is called data at rest, meaning bytes on disk. Then another part of our requirements for protecting customer information is audit. So everything that is done on the database level needs to be recorded. So we have some trail. We need to know who did what at what time. And then another two interesting topics that I wanted to talk about today is user authentication. So what does it mean? Well, we need to give an access to external users and internal users. What I mean by that is that we have BI team, we have QA team, and they all need to get an access to the data, but make sure that we provide this access securely. And then finally, this is probably for me was the most interesting project. This is de-identification or anonymization of the records. For BI perspective, for research and development, for QA, partially for QA as well, but mostly for development and research, we need to give them data, but we don't want to give them the real data. So what we do is we take the data and fake it. And then I will, at the end of this presentation, I will show how we are planning to do this. So let's start with the standard stuff. So first of all, we need to use SSL and TLS for securing our communication. And I will talk about how we do that in MySQL. So anyone here who are not using MySQL at all, not familiar with MySQL? Okay, good. So you're using, which version of MySQL you're using? You're using 5.7? 5.7? Anyone using 5.6? 5.1? 4.0? 3.23? All right, good. So 5.7. So the good news is that SSL, TLS is default in MySQL 5.7. So before MySQL 5.7, in MySQL 5.6, for example, or even early versions, to enable SSL, you will need to basically generate certificates and then copy those certificates to all the client machines. And again, what I'm talking about is about securing communication between the client, the application, or end user, and MySQL. So the good news is MySQL 5.7 by default it is using SSL. So even if you don't have certificates on the client machine, it will still try to use SSL. So what will happen is that when MySQL starts initially, if there's no certificates, it will generate one. For client, it doesn't even need certificates. It will generate it on the fly. But then how do we ensure that our connection is using SSL? Well, that's easy. when we connect to MySQL command line MySQL client, you do status \s, and then you will see that there is SSL here and Cipher in use. So that means that MySQL connection is secure. The same applies to MySQL Workbench. MySQL Workbench will also try to do it. It's a normal client, so it will use SSL if it is enabled. But then what will happen is that the default behavior for a MySQL client is use SSL if available. This is not what I want. I want to force SSL for every client. So how do I do this? So we can create a user and say require SSL. That will make sure that all the connections that will be established to MySQL will use SSL. We can also change this setting, and then we do alter user and require SSL. So that means that all the connections will only be allowed through the SSL. So what will happen? Now I'm connecting here normally, so it should use SSL, and we verify that. Now I try deliberately, I try to skip SSL. So I do -- skip SSL. What will happen? Exactly, access denied. Although I use the same password, same user as previous case, it will show me access denied, because that means that we verified that we only allow connection through SSL. Now, how do we do that in the application? Well, in the application, we can also use that. We need to configure our application to switch to SSL if it's not using it yet. And it's pretty easy as well. And it, of course, depends upon the language. In Python, if you're using connector Python, then it is try to do the same by default. If you're using something like SQL Alchemy, PHP, or anything else, you may need to add some additional arguments. But it's pretty straightforward. Now, the next thing is, how do we secure communication between servers? We have discussed how we can secure communication between client and server, now between servers. Replication, it's also very easy, MySQL replication. So with the MySQL replication, we use this master SSL equals 1, and we will need to copy the keys from master to slave. And when we will do that, then it will also use SSL for sending the data over from master to slave. This is actually specifically important if you do something like different data centers or something like that. The other alternative is to create a VPN connection or something similar to that. But if you're using something like disaster recovery plan and use one data center, another data center, or data center to AWS or something like that, this is specifically important to enable SSL. What about XtraDB cluster? So XtraDB cluster or Galera cluster, there are different implementation of that. Percona XtraDB cluster, MariaDB, Galera cluster. They use the same technology called Galera replication. And because we have 3 servers, this is synchronous replication, there is always a communication between the nodes. Everything that you write to node 1 will be copied over the network and will be committed to node 2 and node 3. So what we'll need to do is we need to protect communication between nodes. But in addition to that, there is a notion of synchronization between the nodes. So if a node joins the cluster, it will request the data, the backup from the joiner. So this backup will also be sent over the network. So our goal is to protect all the communication between the cluster. If the nodes are in the same logical, in the same network, that may not be a problem, but there are lots of companies that prefers to force SSL anyway, and especially if you're working with customer data, health information, it is good to enable and force SSL even through the internal network. So how do we do this? Well, the good news is that we have a single variable now in Percona XtraDB cluster, which says PXE encrypt cluster traffic. So we just need to enable that on all nodes. In addition to that, we'll need to make sure that our certificates, SSL certificates, are the same on all 3 nodes. What happens is this: when a server starts, 5.7 starts, it will generate the certificate. But because all 3 nodes are different MySQL servers running, they will generate different certificates. So what we'll need to do is we'll need to take one node, copy the certificates from that node to all other nodes. It doesn't matter from which node you're copying, but needs to be the same. And then enable this encrypt cluster traffic and then restart all nodes. So that's all, and that will enable all sorts of secure communication node traffic. It will use SSL for connection between nodes and also for sending the backup over. The next topic is about data at rest encryption. So here we will talk about how to store the data on disk securely. And what I have seen when I was a consultant at Percona is there are lots of misconceptions about how to do this and what it gives us. So basically, here are our 3 options that we have to secure the data on disk. The first option is full disk encryption. And this is normal approach. This was a standard approach. We basically encrypt all disks. And there are LUKS encryption, for example, that people are using. The second option is called transparent database encryption, or TDE. So transparent database encryption will encrypt the database files. And the third option is a field level encryption. What that means is that we identify all the fields that contain the health information, and then we will encrypt those fields only. We'll talk about all these 3 options. So let's start with the full disk encryption. There are tools that you can use. For physical servers, you can use LUKS or anything else on Linux, or I don't know, whatever is available on Windows. A second option, if you're using cloud, AWS or Google Cloud or any other providers, probably already have the encryption in place. With AWS EBS, you can use the custom key and encrypt the volume, the EBS volume. When you start your EC2 instance, you can, when you attach a EBS volume, you can specify that you want to encrypt it. And then if you're using some sort of shared storage, you can also potentially encrypt that. That depends upon the shared storage provider. Now, what it will give you is the protection from probably from one very limited case. If someone will pull the disk out and use it. Because if you think about that, what happens is that when the server is up and running, then all files are decrypted. You have an access to that. You have SSH access to your server, and you can read all the files. It's only when the server is down, when you shut down the machine, then the files are encrypted. So in reality, this is good, but may not be good enough. It's good if you're using a cloud storage, for example, and then you start a new instance and then you shut down this instance. That means that this disk blocks the bytes can be reused by someone. We are up to some, or if you're in the data center, for example, you may say, I don't want to use this server anymore. and then it's up to the data center to transfer it to another customer, something like that. So with the disk encrypted, we are protected from that, but we're not protected on any other layers. So another option will be to use the database level encryption. So this is basically the MySQL case, right? So the full disk encryption will protect us from physical access on disk, but if MySQL is running, then the files are not encrypted. In case of MySQL, anyone who has an access to that server can copy those files and do whatever with them. So potentially better option will be to use a transparent database encryption. So MySQL has implemented, MySQL starting 5.7, has implemented the transparent database encryption. The way how it's implemented is this. It creates a master key. Then it will use this master encryption key to encrypt another key, which is a tablespace key. And then it will use that tablespace key to encrypt the actual tablespaces. That's a good implementation because it will allow us to rotate the master key without actually decrypting and re-encrypting the actual data. So what I wanted to do is I want to test it out. So first of all, I wanted to know how many database files will be involved in my single write. So let's imagine I do an insert or update. What will happen on disk? Any guesses how many times MySQL will write it? Any guesses? So let's count. First of all, MySQL has its database, it's durable, it also have multi-versioning, it has a full asset implementation. For that, it will need to have a lots of additional files to support that. So first of all, InnoDB is a storage engine in MySQL, so it will use the table spaces, it will use the redo logs for recovery, it will also use undo log, that is for the multi-versioning. So we can encrypt those, and this is available since MySQL 5.7. Another thing that is used by MySQL is replication logs. Those are binary logs or relay logs. That's I used for MySQL replication, and that can be encrypted as well in MySQL 8 and also in Percona Server 5.7. Anyone is using MySQL 8, by the way? No? Okay. And finally, there are a set of temporary files. If MySQL will do a select, for example, or anything else, it may require creation of the temporary files. This needs to be encrypted as well. So this is available in Percona Server 5.7 and 8. So those are number of links, how it is implemented in different MySQL versions. So what I wanted to do is I wanted to test it out. How do we test it out? Well, I have generated a random string and created a table and then did an insert into this table. So I did an insert and then I did an update, and then I wanted to do what footprint it will leave in MySQL. So after I did this, I expect that I will find this random string somewhere in the files. So I did a simple grep, and I found IB-log file, which is the redo log, binary log is for replication, the actual table which it resides. You remember I created the A table. And then finally the double write. This is another layer in MySQL. And interesting enough, it's not in the IB data file, which I expected to be stored there as well for undo. But anyway, so we have those 4 files here. So MySQL may store data 4 times, 5 times, something like that. So what I want to do is I want to enable transparent database encryption and do the same test to make sure that our random string will not be found anywhere after we enable the encryption. So the bad news is that we need to add all those parameters to my.cnf. What is important? So what I want to do is when I create a table, it will automatically be encrypted. Couple things to point out here. The first is the inhb encrypt tables equals force. Again, this applies to Percona implementation of encryption. Most of those options are actually in, I think all of those options are, except for this one, are now part of the MySQL 5.7 implementation. But I use the Percona server for this test, Percona server 5.7. So inhb encrypt tables equals force means that when you create a table, it will automatically be encrypted. If you don't put it there, that's fine, but then when you create a table, you will need to add encrypted equals y, encrypted equals yes. Another thing is the location of this keyring file. So this is our this is the implementation of the keyring plugin, which will be our key. Potentially we can put it on some mount, and then after MySQL has started, we can unmount it, so the key is secure. But the better implementation will probably be using some key management system like AWS one or something else. I'll talk about that in a second. So now I did the same test. Again, I recreated table A. I did insert the same random string, did the update, and then nothing. So that verifies that our encryption at rest are actually working. This is very quick test, very easy test, I would say. It probably verifies that it is working. Now, finally, talking about the full disk encryption, the TD encryption, is that we can rotate the master key. To do that, it's very simple. You do alter instance rotate inhb master key, and that will change the master key. The good news is that this is very fast operation. The only thing that will do is it will change the master key and then go to all the tables, but will not touch the data. It will only open the header of the table, will decrypt the table space key, and then re-encrypt it with a new updated table key. So it's relatively fast operation unless you have millions and millions of tables. Now, the better way to store the key is HashiCorp Vault or anything else. It is much better than storing in the file. So the HashiCorp plugin is available in Percona server as well. So you can use that, and when you start the server, you will need to load this plugin, and then you can specify where you store it. Don't want to put too much details to go into too much details about that, but this is all documented. So finally, the application level encryption. So application level encryption, or field level encryption. MySQL doesn't have the field level encryption mechanism. So we can do it ourselves. But this is not very easy to do. We are actually doing it at VirtualHealth. But to start with a field level encryption, you will need to identify what kind of data you have and where this data is stored. Then you will need to put that logic into the application. The main issue with that is, I would say, key rotation, because when you have chosen your key, then basically that's it. All the data is encrypted in MySQL, unless you're using some plugin like Vault. HashiCorp Vault can be used to store your keys, and that can facilitate potentially the key rotation. Again, we will have to re-implement what is already implemented in MySQL transparent database encryption. Another issue is searches in MySQL. Let's imagine that we have encrypted, using the field level encryption, encrypted the first name and last name. And then obviously, probably in the application, we'll have some form that will display all our customers and need to sort by first name and last name. How do we do that? Well, because it's encrypted, we cannot sort by that. So we'll have to decrypt it. So that means that if we have lots of users, we'll need to pull it back into the application, decrypt it, and sort it in the application. Or we'll need to create some stored function in MySQL that will do that. Anyway, it will be very slow. So if you will decide to go with a field level encryption, then you will have a problem with order by and indexes. Now, to compare those two options, if you think about transparent database encryption, then it is good, but it is probably not perfect. The thing about transparent database encryption, then again, it is not encrypted inside of the MySQL. As long as you know the password, you can connect to MySQL, do the dump, the MySQL dump. It will not be encrypted, right? The encryption is at rest again. Even if you don't have MySQL password, if you have a root account and root access to that server, as long as you can restart MySQL, it's easy to hack, right? You put this option skip grant stable, you restart MySQL, you kill MySQL, it will come back, and then you have an access to MySQL. Well, the files are encrypted, but you have the full control over MySQL, and then you can do MySQL dump. Second?
If you're root, you can also read the RAM.
Exactly. You can do anything. You can read the key if it's available. I mean, the key maybe not be available. You can attach a GDB and then try to do something else with it. So there are lots of things that you can do with root, of course. So also, if you think about this MySQL dump, if you enable TDE, then the physical backup will be encrypted, but MySQL dump will not be encrypted. So this is also need to keep in mind. So audit log, I don't think we have much time left. So audit log is a feature that is available as enterprise in MySQL and open source in Percona server. In Percona server, it is very easy to enable. Audit log will basically log, by default, log all the queries, everything that is happening inside MySQL, and this is exactly what we want. So if you enable that, it will generate lots of rows in it. You probably will not be able to store it on the same set of disks. If you have a lot of traffic, then it will grow very fast. What we did is we copy that files over, offload it, put it in a log rotation system, and then we store some amount of that on the server, and then we store everything else on a different system. So the audit log will record that may not be the best example, but audit log will record the user that did the query itself, the timestamp, so that if something happens and you want to investigate, you can use the audit log for that. So finally, two other interesting things that I was working on is user identification and data identification. So what is the problem with the user identification? So we need to provide an access, a database access for developers, support, and business analysts. And there are a couple challenges here. The first challenge is security. We need to make it secure. The second challenge is performance implications. We don't want to give the direct access to the server to those people, because sometimes, especially business analysts will create an SQL query that can run many, many hours and put lots of strain on the system, especially if they create a query, they run the query, and then they forget to kill it, and then they create another query. So MySQL is basically running all those queries that definitely can affect performance. So what should we do? What kind of options do we have? Well, we can use the shared account. No. Definitely no. Because if we create a shared account, that's basically an anonymous account, right? So that means that if employer A did something on the server, we don't know if it's employee A, B, C, or D. So we don't know who did that. So it's a big no. Well, another option is to create and manage 30+ MySQL user accounts in MySQL Server. But this is not easy to manage. This is something that I want to avoid. I don't want that. We can do all sorts of automation tools to do this, but it's still not good. We can use LDAP authentication. This is good because many companies use LDAP already. We already have LDAP. And we can connect MySQL to LDAP through the Percona server, or MariaDB has a plugin, LDAP plugin, so they can authenticate users through the LDAP. But the problem is that it's so dependent on Linux implementation, on PAM, so that if I need to implement that, I have to reconfigure hundreds of servers. Currently, we create an infrastructure per customer. Our customers, insurance companies, they each have their own MySQL infrastructure. Not only MySQL, or the whole thing, but includes MySQL as well. So that means that we will need to set up and reconfigure all the servers. Another option is to create a user HashiCorp. HashiCorp Vault can provision the users in MySQL. That's another interesting option and valid option. But that means that it will create MySQL user dynamically. So that means that users will need to first request the credentials from Vault, and the password will be different all the time, which is good, but it's not very convenient to the users to do that. So there is an interesting implementation of MySQL Bastion based on that. But what if we will use some sort of proxy on top of that? So that was my thinking as well. So my Proxy SQL is man in the middle. It's a proxy. I don't know if you're familiar with Proxy SQL or not, but a Proxy SQL can solve the challenge. Proxy SQL, starting with 2.0, have the LDAP plugin, and that will allow us to put Proxy SQL on top, where we use our LDAP authentication through the proxy. This is the architecture that I came with. So for every MySQL host, physical, virtual host, doesn't matter, we set up another service there, Proxy SQL Service. Proxy SQL doesn't, except for the configuration itself, Proxy SQL doesn't have any state. So we can easily provision Proxy SQL on all of our MySQL servers. And then we can connect our users through the PHP Workbench or through the Amazon workspaces to the Proxy SQL using SSL. Then Proxy SQL will use a local host connection. It doesn't even need SSL here on this implementation, although it can do this. It can use a local host connection to MySQL. And then in addition to that, it will authenticate to the LDAP. I put HE proxy on top of the LDAP to basically do the SSL here. So how does it work? Well, we need the plugin first. And in addition to the plugin, we need to configure that. So how do we configure? Well, we need to provide the URI for the LDAP. And then we need to provide some additional variables for bind. Again, Proxy SQL, if you're not familiar with Proxy SQL uses the SQL layer to configure itself. It's you connect to Proxy SQL admin different port and use the SQL commands to configure. This is exactly what I'm doing. At the end of that, I'm just saving these variables to runtime and to disk, so the Proxy SQL will apply those changes. I have 5 minutes, yes, thank you. So now, how do I match? Well, I can use the LDAP mapping. So LDAP supports groups. So what I want to do is, for all of our users, I want to assign a group, let's say MySQL read-only group. So then that will be my access path. If I want to add John to MySQL, I will add, inside of the LDAP, I will assign the group to John. So then I will, inside of the Proxy SQL, I will use this table, MySQL LDAP Mapping, to map the group to the user. So currently, this is LDAP Pro, LDAP RO is MySQL user. So how do I use this? I connect now to Proxy SQL as if it is MySQL. So same protocol. I use a different port. Use a different port here. This is Proxy SQL port. I use my username and I use the password. This is my LDAP, or actually Active Directory account. So then Proxy SQL will do all the job to connect to Proxy SQL, to LDAP. Then we'll search for this account name and then find the mapping. So it will find that my user A Rubin are part of the MySQL RO group in LDAP, and then it will authenticate through the LDAP RO user here. So now if it will be authenticating through the and using this user, a shared user, how do we know that I am doing this select? Well, the good news is it will inject a comment. This is the best part. When I heard about this, I said, oh, that's it. We will be using that. Because that is a big problem solver for us. So it will inject the MySQL user, and the name is here is configurable. You can choose, I chose this, MySQL_user. You can choose whatever you want. And then this is actual user that did the query. All right, I think we have 3 minutes left, and we'll talk about the identification or anonymization. So what's our goal? Our goal is to create a version, a database version without PII and PHI, but still maintain the similar data. So the idea is very simple. I can generate a fake data, a fake users, and basically change. I change myself, I change Alexander Rubin to John Smith. I change the real phone number to the fake phone number. That's actually easier to do than I thought. There is a project called Faker. This project is available in different languages, programming languages. I use the Python. And then I basically generate this table, fake client. I generated lots of rows here to do one-to-one mapping to those fake clients. And this is how it looks like. So this table also have the ID, auto increment ID. So for our clients table, what I do is I create a new table, a client's de-identified table, and then I do a mapping by one using this ID. And then I change the real name to first name to Luke, and then last name to Hensley, and phone number, and address, fake address, and birthday, and social security number, and all that stuff. In addition to that, we may have some text fields, like diagnosis or something like that. Then I use this fake text to exchange the diagnosis to this. Now this can also be generated using different terms. So if we need to have some fake medical terms, we can do that as well. And also this is available in different languages. It is available in Spanish probably, it's available in Russian, it's available in every language. So if you want to fake your clients, your customer information, you can do that as well. So this is how we implemented it. I created a MySQL table, created a mapping table, or mapping by ID randomly, and then create a script to copy the data from source DB to destination DB. That's a very simple script. Do insert, select. What we'll need to do is to know exact fields and exact tables that we'll need to identify, and then we can do that. And then finally, we do a backup. Yep, I'm finishing up. Thank you. We do a backup, package it, and then provision it to the Docker container for our development team. So other options, the last slide, the other options is we may want to do it on the fly. We didn't need that yet to do it on the fly, but to do it on the fly, then you can do something like views. You can create a view, a different database with a view, and then do some functions like random phone or something like that. There's file-based anonymizers. There's a ClickHouse obfuscator that's available to do. This is a good project actually. I was looking for that. The only downside of this is that you have to export data outside of the MySQL. We have a large amount of data. I don't want to basically export it all, do the file-based program, and then load it back into MySQL. So I wanted to do something that is working inside MySQL. There's another project called Gonomizer based on PostgreSQL. That's also it's working on a backup level. So I think that's it. We're hiring like anyone else. We have a MySQL DBA position at VirtualHealth. So if you're interested, then this is the website. I think that's it. All right. Thank you very much.